Good evening, everyone. Let's start. We started our discussion the last time on T tests. We talked about the different type of T tests. One sample T test, independent sample T test, and pair sample T test. We also started talking about the non-parametric counterpart of T test. I think we talked about these sign tests. So we want to look at Wilkinson rank sum and sign rank test and Whitney U now. And I think this data set I'm showing serve as the starting point for the discussion. Let's assume that you can see this data set. You have 20 participants here, first column. That is their number 1 to 20. And we have the first 10. They take substance, drug. So here we are talking about substance use. When we talk about substance, drug, alcohol, many other drugs. So here we talk about drug, number 1 to 10, the first 10 are on drug, and the remaining 10, 11 to 20, take alcohol. So they measure their depression. I want to see the effect of substance use on depression. So they use a scale to measure the Bexin depression index. So the score, you see they measure the depression index on 2 occasions, on Sunday and Wednesday. So the Sunday one, you see the first reading. The Wednesday, you see the first reading. So the way the data is arranged, or data set is arranged, is very useful for both independent, as you can treat it as independent group or as dependent group. For example, now, if you want to independent group mean separate group. So participants 1 to 10, they're a group. 11 to 20 is another group. 1 take drug, 1 take alcohol. So you can actually compare their depression index score on Sunday. That is, you can compare Wednesday also. So you can compare any of them. So what we are looking at now, if you treat them as independent group, you can say, okay, what is the difference in their depression on Wednesday and on Sunday? So there are 2 sets of reading for Wednesday, for Sunday, for these 2 groups of people. You can as well take them, all of them as one group together. They take substance, yes. Or mind you, even the same, okay, we have each of the 2 groups, drug and alcohol. But each of the drug and alcohol, you can see the measurement on Saturday and the measurement on Wednesday compare. The same thing you do for alcohol. For substance use, what is the score on Sunday? And so, you know, if you compare score on Sunday with the score on Wednesday, that's paired. Because it's the same set of people we are trying to look at. These people that take drug, what is their depression on Sunday? What is their compared with Saturday, Wednesday? The same thing with people taking alcohol. So in that situation now, you are dealing with pair observation. So from this perspective, so we are going to look at it as independent and pair observation. Now, the Wilkinson we want to look at, Wilkinson ransom test and Whitney U test. So ransom test, now we are considering them as 2 independent groups. We are comparing drug and alcohol, the pressure among the people that use drug and people that use alcohol as 2 independent. So using the data set in the above, let's imagine a scenario in which there's no difference in depression level between drug and alcohol user. If we run the data ignoring the group to which a person belongs, You just rank, you know the way the scores are. From smallest to the highest. The smallest will be 1, the other one like that. So if we rank from smallest to highest, if there's no difference between the group, we expect a find a similar number of high and low rank in each group. You imagine, so you may have some low in one, low in some, high in the other. So they should be evenly distributed. No, the high and low in one group should not be too much compared with the other group. That is, if there's no difference. Can you see the logic? But if we add up the rank, we expect the sum total of rank in each group to be about the same if there's no difference. In the other way around, let's imagine there was a difference. If there's a difference between groups, let's say the drug group is more depressed than the score alcohol group, that is, the score is higher. If we run the score, we will expect the higher rank to be in the drug group and the lower rank to be more of the lower rank to be in alcohol if a drug is more depressed. If we also sum the rank in each group, we expect the sum of the rank to be higher in the drug than the alcohol. So let's look at this table now. The same, we try to do the scoring, do the ranking. You know, we do separately from Wednesday or Saturday. It doesn't really matter. Just understand one. It's the same thing. It's only that we have Wednesday's data, we have Saturday, Sunday data also. Look at, we have 20 scores because there are 20 of them. Let's say we look at the score, the first row, those are the score. But look at the potential. We try to arrange the score according to in ascending order. Can you see now? So if you arrange in ascending order, ranking, you rank the smallest one up to the end. So at the end of the day, you get up to number 20. That is the potential rank. But in the real life, you know that there are some of these scores that are the same. So, like for example, you see 35, 35, about 3 of them have 35. You cannot rank one 16, another one 17, another 18. Remember in school, if 2 people or 3 people take second position, then they give it to them, but there won't be third, fourth, and fifth. There won't be third, fourth, and fourth rather. If 3 people take second position, you give the second position to 3 of them, all of them became second. But third and fourth will not be there. Because those other 2, in addition to 1 that takes second position, will have taken what will have been number 5th, because you cannot say the next person is number third. No, it's going to be number 5th. So it's the same thing. So look at the actual rank under the Wednesday. You see, instead of putting, you can say 1, 2, because 2 has 6, 3 and 4. You add 3 to 4, the rank of 3 and 4, and divide by 2, give you 3 points. So each of them will be 3.5, 3.5. Then there won't be rank 4. So you go also, you see under number 30, it's called 35. You know, we have 3 of them that we rank 16, 17, 18. If you add the 3 together, divide by 2, give you 17 average. That's why you put average there, 17, 17, 17. In that situation, there won't be actual number 16 and number 18. You have 19 and 20. Can you see? That is the actual rank. So if you now add all the rank together, for a drug, if you add the drug at the one we put D, if you see, just to differentiate, the drug we put D, the alcohol we put A. So if you had all the one that are alcohol together, it's 59. If you had all the drugs together, is 151. So here now it shows that the people on drug, they take higher rank. What it means that their score, the depression score are higher. That's why they tend to have the higher rank. So the way that when you add all the rank together, give the sum to be bigger. So the same thing, if you look at Sundays, the same similar thing we did to Sunday data. So to the extent that the drug also, the sum of the rank is 119.5, while for the alcohol is 90.5. Let's look at the way we do the interpretation. The Wilkinson rank sum and Mann-Whitney U-test both work on a principle explained above. When the group have on an equal number of participants, like for example, that this one we did now is equal number. Drug and alcohol is 10-10. But if there's a when the group have on equal number of participants, the test statistic for the Wilkinson rank sum test is simply the sum of the rank in the smaller group. So let's say we have, let's say it's 11 and 10 now. The one that 10 doesn't really matter. Even if it's higher than the other one, would be the one for the sample size 10, smaller group. That would be the statistic. When these group size are equal, the value of the smaller rank sum rank. So if like in this case now, the value are equal. But you see that for alcohol, the value for the alcohol is smaller. That would be it doesn't mean that they just judge the statistics. So in this example now, 90.5 and 59 for Sunday and Wednesday, respectively. Those are the statistics. That is Wilkinson. Wilkinson just give you what we call, just give you that value. But Mann-Whitney work on it further. So what he now do is that he now calculate his statistics. That statistic will be N1 plus N2 plus capital N1 into N1 plus 1 over 2 minus R1, where R1 is the higher sum rank among them. So if you put this into application now, you see that for Sunday and Wednesday, you see for Sunday, you see 35.5 for Wednesday 4. That is Mann-Whitney. Can you see now? So Mann-Whitney work further. That's why in real life, we prefer using the Mann-Whitney because it's able to quantify it further, make it more sensible. It's further work on the Wilkinson. So if we run it, we look at it, we run the same thing, look at it. We run it with SPSS. All those summary we use and to calculate, look at it. The same thing, tell you the sample size 10-10. The rank for the mean rank, sum of the rank, can you see? Come to this, see the statistics for Sunday, for Wednesday. Now you see the corresponding p-value. I told you, I said something before, for most statistics, the higher the value, the less the p-value. The higher the value of the statistic, the smaller the value of the corresponding p-value. I know that it is when the p-value is small that the difference is significant. When it is as it's becoming smaller. The same thing as the statistic becoming bigger, it's likely to be significant. That is, the corresponding p-value is smaller. But these non-parametric counterpart of T tests, they are exception in the sense that as the statistics become bigger, the p-value become bigger. They move in the same direction. As the statistics become smaller, the p-value becomes smaller. Of course, it doesn't change the fact that the smaller the p-value, the more significant. That shows that as the statistics become smaller, the more significant. You will see now, look at the difference in the depression inventory on Wednesday. The statistic man Whitney U here is 4. Look at the corresponding p-value. You see, look at the corresponding p-value. You see that less than 0.01, that is 0.00. Whereas for the third Sunday is 0.269. It's not significant. You will see that the statistic for Sunday is higher, 35.5. That is Man Whitney, while Wilkinson is 90.5. We've seen it. But look at Wednesday. This Man Whitney is 4. The Wilkinson is 59. So the statistic is smaller on Wednesday than Sunday. But it's more significant that same Wednesday because the corresponding p-value. Look at the p-value. So from what we have seen now, there's difference in the depression between alcohol user and drug user on Wednesday, but there's no difference on Sunday. I don't know if there's any question, let me know. So some of these things now, for our own, we are not even doing exam. Even the people that are our postgraduates, we didn't give them, we don't give them this one to be solving. Just give them T tests or the chi-square, just to, but my own is for people to understand the logic, then know how to use machine, the software to run the analysis, interpret the results. That's the most important thing. So if let's move further to look at the other aspect. This is the non-parametric counterpart of dependent pair. So we now look at, we have just finished the non-parametric counterpart of independent sample T test. But for dependent sample T test now, we have Wilkinson sign rank. You know the other one is Wilkinson rank sum. So we just finished Wilkinson rank sum and Man Whitney U for comparing two independent samples. But if they are pair, now I've already told us this data set, you can look at it from the pair aspect. For each of the drug and alcohol now, you can compare the pressure on Sunday and Wednesday. Because the pressure on Sunday is on the same person. On Wednesday, it's on the same person, so it's paired. So when we look at it from that perspective, you can see, let's look at it, the data set again. So this Wilkinson sign rank test is the non-parametric counterpart of dependent pair T test. It's used in situations in which there are two sets of scores to compare, but this score comes from the same participant. If we are interested in the change in the pressure level within people, I think within each person, for each of the two drugs, we now want to compare the BDI, that is Bexin depression index score on Sunday to those of Wednesday using Wilkinson sign rank test. We can see the name sign. That's why I make it different from sum. That one Wilkinson rank sum. Both of them have rank. You rank them better. This one, that one sum, summation, this one is sign. The sign he's talking about here, you're going to see is plus or minus. So for the one that is for pair, is about plus or minus sign. Which one is higher? If you remove, you minus something higher or smaller, I give you negative sign. If it's something smaller, you have minus from higher, it give you positive sign. That's what it's just said. So let's look at this. Look how we did it separately for drug and just like the way we did separately for Wednesday and Sunday. Here now we are doing it separately for alcohol and drug. So for drug, the first one, look at the score on Wednesday, the second column. No, the first column is score on Sunday. The second column is score on Wednesday. Then you have to know the difference. You remove one from the other. You remove one. From here now, I think we remove Sunday from Wednesday. Yeah, you gotta look at the sign. Anyone that they are the same, the difference will be 0. Once the difference is 0, you exclude it from the calculation under the sign. You want to know the sign. That is when you remove it. Does it have negative sign or positive sign? The one that is 0 has no sign. It's neither negative or no positive. So here now, when you remove Sunday from Wednesday, or we have already, so it's obvious here that Wednesday, the score, the pressure is higher on Wednesday. So when we remove Sunday from Wednesday for drug, all of them, they are positive. That is, all of them on Wednesday, the value are higher than Sunday. So it's positive direction. But if you look at the alcohol, you see that when you remove Sunday from Wednesday, some have negative. Can you see? We have some that have positive, some have negative. So you can see. So you see the rank now for each of, you have to now rank the difference. Rank the difference. Either you rank, forget about the type of sign they have. You rank the difference. When you rank the difference, so how many belong to positive rank? Like for the drug now, all of them belong to positive rank. So when you add all the rank together, they are all positive, 36. But the negative is 0. But for alcohol, when you round the positive, they are 8, and you add all the negative rank, 47. That's it. So the drug, for the drug now, total positive is 36, total negative is 0. But for alcohol, total positive is 8, total negative 47. The test statistic T is the smaller of the two values. 0 for drug and 8 for alcohol. So if we run it in SPSS also, this is what it gives us. We look at the statistics here. For the drug, you see that both of them, of course, they are different, because when you have 0 and the 36, and you have 8 and 47, the difference is much. You can see that there's a difference, because the p-value for the drug is 0.012, while for the alcohol is 0.047. Both of them are statistically significant. So I don't know if there's any question. The median test, there are some other tests, but I just feel that it's not even wise to bother you with. So we have the example here, elaborate example on, because some of them, we're hearing that median test is actually a form of chi-square. So I don't want it to, it just feels like there are some things that are not necessary. But I felt that if you begin to swallow them, you begin to have issue. It can confuse the little you've learned. So though I put it there, but I usually explain it, but I just feel that it's maybe something that to give it too much at a time. It can confuse because the most important thing is for you to know, okay, there's this man within you that you use as non-parametric counterpart of field-dependent T test. And also Wilkinson sign rank test, which is used as non-parametric counterpart of peer T test. That's all. And it's the same thing you use, what you use for peer T test is what you use for one sample T test. I don't know if there's any question. Any question? Because sometimes if there's no questions, maybe it means that we are not following, or what? But everything just look. Because if you have questions, it will be more interactive. Ask questions and maybe able to explain some more active. Any question? Are we all in the class?
Yes, sir. I am.
So if there's no question, it's a short one. It's just to complete what we have done before. So the next time will be okay. Somebody shouted. Okay, so well understood. The next one now we have finished with T test and the non-parametric counterpart. I think we have discussed chi-square also. Let's look at. We go to measure of association first before we go to ANOVA. Let's do measure of association. Under the measure of association, we'll be looking at relative risk odds ratio. So what warrant the use of all those statistics, relative risk and odds ratio. Then even hazard ratio, even though that one is used in survival analysis. We look at the concept so that we can understand. But most of the time in the epidemiological study, every study we usually use most of the medical literature. You hardly see where people compare me, even when people do chi-square, where they go on to do logistic regression, which we are still going to discuss also. But most of the time, you see something like relative risk, odds ratio, when they are talking about case control study, cohort study, they talk about all the statistics. So we look at it. That will be the next thing we look at, measures of association. So if there's no question, I can stop here. Thank you for listening.
Thank you, sir.